All right, guys, today we're going to finish up looking at parallelogram theorems. So we've done the first two, and then we're going to look at these last two down here on the bottom of your handout. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So just as a reminder, supplementary means that they total 180. So if you've forgotten that, let's just write that down here, that means it equals 180 degrees, okay? That's what supplementary means. So what we're saying is, if we have a parallelogram, and we're looking at, say, these two angles right here, they're consecutive angles, these two. If we add those two together, if we add them, they're going to be 180 degrees. We could say the same thing about the two angles at the top, the two angles over here on this side, and the two angles at the bottom. So as long as they're consecutive angles, they're side by side, then when you add them together, they're going to equal 180 degrees. So let's look at an example of that. It says find the unknown variables. All right, these two are located down here at the bottom. So what that means is these two have to be supplementary. There's a couple different ways you could work this. You could do 180 minus the 135. Get what that answer is, and then set it equal to 9x. I'm going to set it up so you can see the equation. We know that these two added together, 9x plus 135 has to equal 180 degrees, okay? So then, once we do that, we're going to subtract that 135 from both sides, which gives us 9x is equal to 45. Then we're going to divide both sides by 9, and that gives us that x is 5. So x is equal to 5. All right, for the next one, we have two different ones we need to solve here for. We need to solve for x, but we also need to solve for y. Doesn't matter which one you do first, I'm just going to do x first. I know that these two added together, 5x plus 20 plus 120 has to equal 180. Those two added together have to equal 180, okay? So I'm going to combine like terms on the left. 20 plus 120 would be 140. Then I'm going to subtract 140 from both sides. That gives me 5x equals 40. Divide both sides by 5, and we get that x is 8. X equals 8. All right, to solve for y, there's a couple different ways you could go about doing this. We could do the same setup to solve for y here. So now we know that 8y plus 4 plus the 120 has to equal 180. You could have also taken the x and substituted in it up here, got what that is, and that would have been what? 5 times 8 is 40 plus 20 is 60. Set that equal to the 8y plus 4 and solve for y. I'm just going to do it this way because it's the way I did this one, okay? So 8y plus combined like terms gives me 124 equals 180. Subtract 124 from both sides. That gives me 8y equals 56. Divide by 8 on both sides, and we get y is 7. Oops, y equals 7. Okay, we've got one more set of theorems to look at for parallelograms, and that is over here on this side. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So let me show you what we mean by that. So if we draw us a parallelogram down here, a diagonal looks something like this, goes from one edge to the other like that, one corner. So one corner to the other, those are our diagonals. And what this is telling me is that this and this are congruent because they bisect each other, so they create two congruent segments here. And they also create two congruent segments here. So these two sides are congruent to each other, and these two sides are congruent to each other. Okay? That's what this theorem tells us. So let's look at an example. Okay, so what we're saying here for this first example is that 5x minus 1 has to equal that 14. This is a diagonal bisector. They bisect each other. So that means it creates two congruent segments on each side. So I know that 5x minus 1 has to equal 14. To solve, we're going to add 1 to both sides. That gives us 5x equals 15. Then divide both sides by 5, which gives us x equals 3. For the other diagonal, we know that 9y has to equal 18. So 9y equals 18. Divide both sides by 9, and that gives us that y is equal to 2. All right, let's look at our last example over here. This time we have x's and y's to solve for again. So first I'm going to start with x. This is congruent to this because our diagonals bisect each other. So I can set 5x minus 8 equal to 4x plus 4. I'm going to start off by subtracting 4x. That gives me x minus 8 equals 4. And then I'm going to add 8, which gives me x equals 12. Okay, the same thing follows for my y's. 7y plus 2, this side, will be congruent to this side, which is 10y minus 7. So I know that 10y minus 7 has to equal 7y plus 2. I'm going to start by subtracting 7y from both sides. That gives me 3y minus 7 equals 2. Then we're going to add 7 to both sides, which gives us 3y equals 9. Divide both sides by 3, and we get that y is equal to positive 3. All right, guys, as always, if you have questions, let me know.